Using mathematical induction, prove that factorial n is greater than 2 to the power n for n is greater than or equal to 4. Mathematical induction involves 3 steps. First one, we need the statement. So let Pn be the statement factorial n is greater than or equal to 2 to the power n for n equal to 4, 5, 6, 7, and so on. So we are saying this to be just a statement. We are neither saying it to be true nor it is to be false. So that is the statement. Now once we got the statement, we need the starting point, and lastly we need the cycle. So let's get the starting point. Therefore P4 is the statement factorial 4 is greater than or equal to 2 to the power 4. Is that true? Factorial 4 is 24. 2 to the power 4 is 16. That is, 24 is greater than or equal to 16, which is true. So we got the starting point to be true. Therefore, P4 is true. Now once we get the starting point to be true, we need some kind of cycle so that we can continue further. So to get the cycle, we assume something true. So let us assume Pn is true for some n greater than or equal to 4. Let us assume Pn is true for some n equal to k. So that is, we are assuming pk is true. That is, we are assuming factorial k. We are assuming factorial k to be greater than or equal to 2 to the power k. Now somehow we want to show that Pn is true for some n equal to k plus 1. So somehow we want to continue the cycle. Whenever pk is true, we want to show that pk plus 1 is true. Then factorial k plus 1 equal to k plus 1 times factorial k, which is greater than or equal to, in fact it will be strictly greater than, factorial k is equal to as well, maybe equal to as well. Factorial k is greater than 2 to the power k, but k being greater than or equal to 4, k plus 1 will be greater than or equal to 5, so definitely that is always strictly greater than 2. So we can say that factorial k plus 1 is strictly greater than 2 to the power k plus 1. That is, factorial k plus 1 is greater than or equal to 2 to the power k plus 1. So what do we get? We get some kind of cycle. So pk plus 1 is true whenever pk is true. If we, of course there k has to be 4 or 5 or 6 or so on. So we know that pk to be true, starting p4 is true. From this statement we can say that p5 is true. Again taking k equal to 5, we can say that p6 is true. Again taking k equal to 6, we can say that p7 is true. In other words, pn is true for every n. Hence, by principle of mathematical induction, we can say that factorial n is greater than or equal to 2 to the power n for every n greater than or equal to 4. So we just need to get some starting point. In this case, n turns out to be 4, that's the starting point. And we need to show that Whenever pk is true, pk plus 1 is true. And then we can say by principle of mathematical induction that Pn is true for every n.